All right, guys, so welcome to 6.3 Part 1, the Law of Cosines and Applications. Before we get into the Law of Cosines, I want to remind everybody about the Law of Sines. That from the last video, there were three situations that we used the Law of Sines. When looking at a triangle, we were either given angle, side, angle, angle, side, or the ambiguous case, side, side, angle. The reason I bring this up is anytime you use the law of sines, it is possible that we could be dealing with this ambiguous case. So as a suggestion today, when we're going through the law of cosines, if you start with the law of cosines, I would do the entire problem with the law of cosines so that you could avoid this possible case where you could have two different triangles. So just a little hint before we begin. So the law of cosines is yet another formula. And if you take a look at it, it kind of reminds me a little bit of the Pythagorean theorem. And in fact, the proof is from the Pythagorean theorem and a little bit of similar triangles and whatnot. But when I looked into the proof would actually take a lot of this video to do. So I decided not to do it today. However, I do know that there are links online that would show you where the law of cosines came from if you're interested. What I want you to notice about the law of cosines is there's two situations that is used for. When you're given side, angle, side, so that would be something like side, angle, side, or if you're given a triangle with three sides, side, side, side. So unlike sines, cosine is used in a different situation. Something else I'd like you to notice is that this is probably the most popular equation for the law of cosines. I want you to notice that the side that everything is equal to goes with the angle in the cosine. So A, B, and C doesn't mean as much as you noticing that the side that everything is equal to goes with the angle across the way. Please keep that in mind again as we keep going. This formula over here is really just this one rearranged. So I want to show you where this comes from, even though to be honest, you're going to see me use this equation a lot more today. So if I were, let me erase this, if I were to isolate the cosine of A, we'll get this alone, you would have to move the least attached things first. The negative 2 times B times C is attached, so what I'm going to do is move B squared and C squared over here by subtracting. So we'd have A squared minus B squared minus C squared equals negative 2BC cosine of A. Then if I wanted to continue to get cosine of A isolated, I would divide both sides by the product of negative 2B and C. This would cross out. So you'd have cosine of A equals A squared minus B squared minus C squared over negative 2BC. And if you take a look, the only difference between what I did here and here is that all the signs are flipped. So what happened was really multiplied by negative 1. But I want you to know that in the video, I will be generally doing everything with this equation. So let's actually apply this, shall we? So you can see what the law of sine or law of cosines really does. Solve the triangle. So again, you want to find every missing side and angle that you don't have. So the first thing I want to do is again just draw a general oblique triangle given three sides. C is the longest side, so I'm going to call this angle capital C. A is the second largest, so I will call this 55, and I will call this capital A, which leaves this as capital B, or 25. So it looks like we're given side, 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 which is a law of cosines idea. So what I'm going to do is think about how I can apply this formula. Again, I want you to notice that A doesn't mean as much as just noticing that the side you're trying to find goes with this angle. So when you're trying to solve using side, 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 in general, you want to always find the largest angle first out of good habit. Again, we're going to try to avoid using the law of sines today, just using the law of cosines. So the largest angle in this case would have to be across from 72. So this is the angle I'm trying to find first, which means if I'm trying to find C, that means my equation has to start with C squared. So here would be my equation in this circumstance. C squared would equal the other two sides added up, just like previously, the two sides added up, and notice the two sides added up are also used in the multiplication. So this way would be C squared equals A squared plus B squared minus 2AB cosine of C. So remember, these two go together. So let's plug in what we know. We know that C is 72. So 72 squared equals A, which is 55 squared plus B, 25 squared, minus 2 times 55 times 25 cosine of C. And we again are trying to get what the angle is so we can solve the triangle. So if I wanted to isolate the cosine of C, we could do the same thing that we did back here and get the cosine by itself. So here's what I would do. I would subtract the 55 squared and the 25 squared to the other side. So I'd have 72 squared minus 55 squared minus 25 squared equals negative 2 times 55 times 25 cosine of C. And our goal is to do this completely in the calculator. So now I'm going to divide by the product. And this would cancel. So you'd have cosine of C equals 72 squared minus 55 squared minus 25 squared over negative 2 times 55 times 25. So if you don't have your calculator out already, please do. I'm going to have mine here. And earlier, I actually already put in the first part of this just to save a little time. So if I want to find cosine of C, first thing in your calculator is you want to do 72 squared minus 25 squared minus 55 squared. Then I would press enter, and I got 1,534. Now, you want to divide that number by all of this product. So in your calculator, don't remove anything. In your calculator, when you press divide, there's that current answer. Please put parentheses because you are dividing by the entire product. Negative 2 times 55 times 25. And when I do that, I get that the cosine of C equals negative 0.5578. Now, if I write that the other way, cosine of C equals negative 0.5578. You might recognize this from earlier in the semester, is that if I want to solve for C, we can't divide by cosine, but we can take the inverse cosine of both sides. So over here it would cross out. You get the cosine of C equals the inverse cosine of negative 0.5578. So in the calculator, again, to save time, what I would do is press second cosine and then just second answer because it has nothing rounded. If you press enter, it looks like my actual angle measure is 123.905 degrees. 123.905 degrees. So I'm on my first step to solving the triangle. Now, in the notes here, I showed every single step. For some of you, you're going to, over time, get much more quick at this because you're doing everything in the calculator. I'm just writing down my work. Unfortunately, we're not done with the problem yet. We found that angle C here was 123.905, but we need to find these two angles as well. So let's use the law of cosines again to find another angle. So this time, let's find, I don't know, I'll do a different color. Let me pick purple. Let's find angle B. If I were going to find angle B, we need to use the law of cosines, but this time, if we're finding angle B, the side across from it is 25. So we'd start the law of cosines with 25 squared. So we'd have, let me extend the page here, we'd have 25 squared equals 55 squared plus 72 squared minus 2 times the two sides we just used, cosine of B. So what I'd like you to do, just like last time, is I'd like you to isolate the cosine of B, and I'd like you to plug everything into your calculator and see if you can find B on your own. Keep in mind, once you find angle B, you can find angle A because you know that a triangle adds up to 180. So please pause the video now and try this on your own. All right, guys, here was my work. I isolated cosine of B. When I plugged this in the calculator, I got 0.957575. Took the inverse, got 16.749 for angle B, which meant when I subtracted those two angles from 180, I got that A should be 30 9.346 degrees. Please pause the video if you need to copy anything down. The next example, solve the triangle. So again, let me draw a general oblique triangle. C is an acute angle, so I'll put it here. A is a larger side, so I'll just put it here, call this A, which means this has to be B, and I'll call that 2.15. So when I look at the triangle, I notice that I have side, angle, side, which is another situation that works with the law of cosines. So luckily this time I have the angle. So what if we found the side across from the angle? You might find this is a little easier. If we're looking for c squared, we have to use the other two sides. C squared equals the first side plus the second side minus 2 times the two sides I just used, 2.15 and 6.25, cosine of the angle across from the side that I want, 15.25 degrees. So what I'd like you to do, again, is pause the video, because this can be plugged directly into your calculator, and then you can just take the square root of c. So please pause your video, plug this in, and I'll be back with my work. All right, guys, so I took all of this green and plugged it exactly into my calculator, including the -2 times this, times this, times this. When I plugged that in, I got the answer to be 17.756. So let me write that down. C squared equals 17.756. But please don't forget to take the square root of both sides. The good news is you don't have to remove it from your calculator. Just press second, square root, second, answer. Sorry. And when you do that, you would get 4.214. So C is 4.214. So we've solved for the missing side, but now we need to find a missing angle. So to focus you, I would like you to find angle B by noticing that you'd start with the side across from it, just like we did on the last couple of examples. So again, I'd like you to pause the video, use the law of cosines to find angle B, and then use the fact that a triangle is 180 to find angle A. I, again, will be back with the work. All right, guys, here's my work. I plugged everything in, isolated cosine of B, got 0.99094 from the calculator, got that B was 7.718 degrees, then found angle A because I know a triangle is equal to 180. So again, feel free to pause the video here if you would like to copy anything down. All right, guys, please take a minute, pause the video, and please read the problem first. So I noticed at the beginning of the problem, we're at 4 p.m. and then we have 6 p.m. at the end, so we have a 2-hour span. One ship is heading at a bearing of north 38 east. What that means is from the port, you're looking north and then you are turning to the east. So this is your 38 degrees. And the other ship is looking south and then it is turning east, so this is 47 degrees. Now, I noticed that these three angles are along a straight line, so they add up to 180, so this remaining angle in the middle would be 95 degrees. Also, we can find these two lengths. This first length, we know the ship is traveling at 11.5 miles per hour. I'm sure some of you have heard of distance equals rate times time. If the first ship was going 11.5 miles an hour in 2 hours, its distance would be 23 miles. So A is really 23, and the second distance, the second rate given, is 13 miles an hour times the 2 hours. So its distance would be 26 miles. So what I want you to look at is now you have this triangle where you're trying to find this distance between the ships and you're given side angle side. So you can use the law of cosines. So what I'd like you to do is pause the video here, see if you could find D using what we've been doing. I'll have the work when you come back. My answer was 36.183 miles. Feel free to pause and copy. This last problem, I drew the triangle for you and drew this line with these hints to talk about bearing. Please try this one on your own and I will have the answer for you in a minute.